When it comes to fighting failures, the most effective approach is actually to prevent them from occurring in the first place. This involves making good decisions throughout the entire development process, from the way you write the code to the tools you employ and the overall culture of quality that you have in place. The key principle here is to establish safeguards as early as possible in your development process. The earlier you identify an issue, the easier and often cheaper it is to solve. Now, this is an idea known as shifting left. If we imagine our development process as a pipeline running from left to right, we want to find issues as close to the left of that as possible. The really important goal is to detect problems before they hit production. So if we find an issue before it hits production, then we've effectively prevented it. How do we achieve this in practice? Let's break it down. We'll start with the choices that you make when you're writing the code itself. First of all, we've got choosing an appropriate architecture. So when designing a code base, it's vital to consider both maintainability and flexibility. Not spending enough time thinking about these aspects at the start of a project can result in a fragile, complex, and hard to extend code base. Over time, making changes or adding features can become increasingly challenging and can lead to bugs. Here at Ghyston, we've had a lot of success with what's known as a vertical slices architecture, and that's where we organize code around features rather than application layers. And we found that this gives us the perfect mixture of low coupling and high cohesion in our code. Cool, so next up we've got static type checking. Here at Ghyston, we're strong advocates for writing software using statically typed languages. Writing code in a statically typed language can really help to catch mistakes at development time and actually boost confidence during refactoring. And this is very much in line with our shift left approach. So using something, let's say TypeScript instead of JavaScript, can really force you to think about and declare your intent in the code, which can actually enhance code quality and readability as well. Next up, don't reinvent the wheel. So one of the most effective ways that you can avoid issues is actually to make use of existing open source libraries whenever possible. Established libraries are much less likely to contain problems since they're typically maintained by people with specialist knowledge, and they're rigorously tested in production by thousands, if not millions of developers who are using them. So trying to create your own solutions, especially in areas like user authentication, can actually be really dangerous. And things like don't roll your own auth is a saying amongst software developers for a good reason. Next up, we've got automated tests. So building a comprehensive suite of automated tests is a huge factor in preventing issues. These tests act as a safety net to catch and prevent problems before they make their way into production. Again, this follows the principles of shifting left, but tests also have a lot of less obvious benefits. So for complex code, writing tests as you go along can actually make it much easier to design features and ensure you've covered all of the different edge cases. And tests also serve as really good documentation, which makes it easier for developers to maintain the code in the future. Okay, now let's move away from the code itself and look at tooling. So using the right development tools can be a really effective way to prevent issues, especially through automation. Firstly, integrate code quality tools. So some IDEs can detect code issues and often offer quick fixes right there in the editor. There's also command line tools, things like ESLint, which can analyze your code and warn you about potential problems. These tools can be integrated into your IDE so that you get the feedback as you're writing the code, and they can also be dropped into your continuous integration process, and that will ensure that every new piece of code that gets checked in is checked for quality automatically. On the subject of automation, you should obviously automate as much as possible. So manual processes carry with them a risk of human error, while repeatable automated processes carry a much lower risk. It's particularly important to automate things like your build and release processes. So obviously the consequences of missing a step here could be very serious. At Ghyston, we're big fans of defining our build processes using a fully fledged programming language. So tools like Nuke build for C# allow us to build our build process up as code and run it and debug it locally. Okay, to finish up, let's talk about the role that humans play in spotting and preventing issues. So good code and good tooling will only get us so far, but fighting failure effectively also relies on human factors, culture, and processes. Firstly, there's code reviews. So computers can be incredibly effective at detecting problems, but there are a lot of things that only a human can spot. Code that technically works may still have issues related to code quality, or it may not correctly represent the desired business logic. So code reviews are a really important part of our shift-left approach. Then there's manual testing and QA. So even with automated tests and code review, issues can still slip through. So while developers can and should perform manual testing of their own work before pushing it out, testing your own work can give you a false sense of security, especially if you've made some fundamental misunderstanding somewhere along the line. So having a dedicated QA process where work is tested by someone other than the developer who delivered it is really essential to catch any issues that have been overlooked. Okay, so we've talked about a lot of tools and techniques here, and while they all provide value in their own right, it's important to note that the full potential is only realized when they're applied together. So if we imagine a Swiss cheese, a single slice has lots of holes in it, but the block itself is solid. So each method we've discussed here is like a slice, and you need to put them together to effectively prevent failure.